Let us discuss this result. Okay, so see, we are already familiar with this result. This result says if you have two real numbers having product is negative. So I think in 5th or 4th standard we have already studied product is negative, that means 100% one number is positive and the second number is negative. So here we have written either x is positive, y is negative, or x is negative, y is positive. We have studied this part, but see, we are going to prove it now. So let me write the given thing first. We have, just a minute, okay, so we have, what we have, x comma y belongs to R such that what we have, x into y less than 0. This thing we have. Okay, see, I will focus on x first. You remember the law of trichotomy? Law of trichotomy says if you have any real number, exactly one of the three conditions is true. Either x is equal to 0, or x is less than 0, or x is greater than 0. So I will mention for x belongs to R by law of trichotomy, that we will have x is equal to 0, or x is less than 0, or x is greater than 0. We are going to discuss all these three cases. Case number 1, x is equal to 0. See, if x is equal to 0, what will happen? Then x into y, that means 0 into y. You know that 0 into y is 0, but it is not possible because they have mentioned x into y is less than 0 and we are getting x is into y is equal to 0. So I will mention this is not possible because x into y less than 0. So therefore this case fails. That means this case is not useful for us. Okay, so let us go for second case, case number 2. So what is case number 2? X is less than 0. X is less than 0, that is x is negative, getting x is negative. So what we have here, we have x into y is less than 0, right? What we have, x into y is less than 0. See, I am going to divide both sides by x. Dividing both sides by x. So what will happen? Xy upon x and 0 upon x. But see, when you multiply or when you divide by any negative number, we will have exactly opposite inequality. Here we have less than and we are dividing by negative number, so we will get greater than, right? So x will get cancelled and we will have, I will write here, y greater than 0. X cancel y, 0 upon x is 0. So we got y greater than 0. So therefore, in this case, we get, what will we get? X is less than 0 and y is greater than 0. So this thing we proved. X is less than 0 and y greater than 0. So in this way we completed second case. So after that we have a third case. Third case is, see, x is greater than 0. Okay, I am going to discuss it. You can make a screenshot of it and after that we will go for last case. Let us discuss third case, that is x is greater than 0. See, x is greater than 0, that is x is positive, right? X is positive. See, let us start with a given information. We have xy is less than 0. So we have xy is less than 0. What I am going to do, I am going to divide both sides by y. Dividing both sides by y. So, sorry, both sides by x. See what will happen? Xy upon x and 0 upon x. See, when you divide or when you multiply by any positive number, we will have the same inequality. So here x is positive and we are dividing, so we will maintain same inequality. X will get cancelled, y less than 0 upon anything we will have 0. So therefore, in this case what we get x is greater than 0 and y is less than 0. In second case, you remember now our first case it fails, okay. Second case x less than 0, y greater than 0, and the last case x greater than 0, y less than 0. So therefore, from all three cases we get, we get x less than 0, y greater than 0, or x greater than 0, y less than 0. So in this way we proved, okay. So see, one more example we are going to discuss, but you can make a screenshot of it and then we will go further. See, let us discuss this result, a very small result. What we have to prove? Additive identity is unique. You remember additive identity? Additive identity, that means a number. If you add that number in any number, we will have a same number. Okay, you know that 0 is additive identity. If you add 0 in any number, you will have a same number. 0 plus 5, 5. 0 plus 9, 9. Getting now? So here we have to prove that it is unique. There is no any other number. 2 is not additive identity. If you add 2 in any number, you will have same? No. So, but mathematically, we have to prove there is only one such additive identity. So, let us prove it. See, suppose, just a minute. See, in mathematics, when we wish to prove something, most of the times what we do, we assume exactly opposite. And after that, by solving few steps, we get a contradiction somewhere. So we declare our assumption is wrong, and that's why we get an actual result. So we have to prove it is unique. Unique means only one. Okay, so I will assume there is no one. There are two. Getting? I will assume there are two additive identities. There are two numbers. Okay, which are additive identities. So suppose 0 and 0 dash are additive identities in R. So I am assuming there are two identities, 0 and something 0 dash. We don't know what is 0 dash, but I am assuming, okay. So there are two identities. So that means by definition, so therefore x plus 0 is x. 0 is additive identity. So that's why if you add 0 in any number, you will have a same number for all x belongs to R. I will call it as equation number 1. And second, x plus 0 dash is again x, because we have assumed 0 dash is also another identity. So this thing we have assumed. So by assumption and by a property of additive identity, it is true. Okay, so by our assumption, I have got these two things. What I am going to do in equation number 1, I am going to put x is equal to 0 dash. See, what I am going to do, putting x is equal to 0 dash in 1. Tell me what will I get if I put x is equal to 0 dash. Therefore, 0 dash plus 0 is equal to 0 dash. Equation number 3. Okay. And in equation number 2, I am going to put x is equal to 0. What I am going to put? X is equal to 0. Putting x is equal to 0 in 2. What will I get if I put x is equal to 0 into? Therefore, 0 plus 0 dash is equal to, I am putting x is equal to 0. I got equation number 4. Right? So you know addition is commutative. That means a plus b is same as b plus a. So addition is commutative. We know that addition is commutative. Getting? Addition is commutative. That means, therefore, 0 plus 0 dash is same as 0 dash plus 0, since addition is commutative. A plus b is same as b plus a. This is equation number 5. then see, from 3, 4 and 5. 3, 4 and 5. See, 3 says 0 dash plus 0 is equal to 0 dash. 4 says 0 plus 0 dash is equal to 0. And 5 says 0 plus 0 dash is equal to 0 dash plus 0. So if you consider 5 says, see, left hand sides of 3 and 4 are same, right? 5 says left hand side of 3 and left hand side of 4, both of them are same. If left hand sides are same, right hand side should be same. So therefore 0 dash is equal to 0 since their left hand sides are same. Getting that means, suppose if you have x is equal to a, if you have x is equal to b, both have the same left hand side. So that's we write right hand sides are also same. That means a is equal to b, we write easily. So same thing, by applying same logic, we can say left hand sides of both equations are same, 5 says. So therefore right hand side should be same, 0 dash is equal to 0. So we started with two additive identities, and finally we got both of them are same. So that means there is only one identity. For example, okay, what is a technique, what is a procedure, what is the logic behind it, you can easily understand. Suppose in your class, okay, I have to prove there is only one student having name Paresh. Okay, what I have to prove, in your class there is only one student having name Paresh. So I will assume contrary. Suppose there are two students having name Paresh, Paresh 1 and Paresh 2, and I am applying some logic and statements I am getting, and finally I am getting Paresh 1 is same as Paresh 2. Both of them are equal. That means there is only one person having name Paresh. So yeah, same technique we use here. So here we proved 0 is equal to 0 dash. So therefore what can we conclude? Additive identity is unique in R. Additive identity is unique in R. So in this way we have completed. You can make a screenshot of it, and after that we will stop. Thank you. Bye bye.